All right, so welcome. This is a presentation on TELLab, which is the experiential learning lab. And I'll be explaining more about what TELLab is, how it works, and what you can do with it. I should say it was started by Ken Nakayama. The first version was built by Na Lee, and there have been dozens of helpful people who've collaborated on it so far, and we're also working on a next version. So many folks associated with VSS know Ken Nakayama. He's had lots of good ideas. One of his good ideas was VSS around 2000. Another good idea around 2014 was TELLab. And Ken's not with us this morning. He's on vacation in London, and he needed a vacation. It's been a long year for everybody. So I should mention at the start that this presentation is roughly the same as one given in 2020. And so if you were at that presentation, we've got another follow-up for you, another workshop. But what we're going to cover is a reliable, well-tested website for teaching students how to do research. And we've got a second version of TELLab under construction. And if you want to learn more about that, there's presentations on Monday at 8 p.m. and on Wednesday at 2:30. And so TELLab 1.0 is well tested. We're pretty sure it's bug-free. I've been using it in my classes for 5 years, so it's reliable, stable. TELLab 2.0 is under active development. It's got more functionality. It's going to be better than 1.0, but it's not fully tested yet. It doesn't have the battle-hardened experience of classrooms that the first version has. So if you want something to use to teach, say, a class this summer, TELLab 1.0 is probably your best bet. If you're thinking about innovative solutions for the fall and beyond, TELLab 2.0 will probably be your best bet. So what is TELLab? TELLab is a free online platform for learning by creating psychology experiments. And the focus is experiential learning. So it lets you participate in experiments. You can send your students there and they can do a Stroop experiment or a change detection experiment or an MOT experiment or something else. And you can immediately download the data that you generate. So it gives students this really hands-on feeling of how we generate data files, right? You were just the participant, and now all of a sudden you've got a data file, and every line is a button that you pressed and something that you saw. So it gives a really immediate link between the experience of being a participant and what the data generated by that experience look like. So it's a nice way to get students started to understand data sets and to make them relevant to them. Too often students are trying to analyze data that they don't know how they were produced and they don't care about them. But if you were just the participant, now the data makes sense to you and you care about them. So those first two options, there's other software out there to do that. It's nice that TELLab supports it as well, but we've also got some innovative things with TELLab. So we have a GUI editor, an online data collection, and this means that your students don't have to learn how to program in order to start building experiments right away. There's a number of ways they can interact with the editor. One thing is you can copy and modify any experiment on the website. So you can copy it into your account, and now you've got an editable version, and you can make tinker with little changes. You can change the timing of things. You can swap in different stimuli if you want. So it's really easy to get started editing experiments by working with existing templates. Students can also build entirely new experiments from scratch, and then they can collect data online. So they can get a link, they can send it out to a listserv, or they can post it on Facebook, or they can share it over email to people that they want to participate, or they could potentially use mTurk and collect data that way. So all the data collection's online, and that makes it really, really accessible. It works at home during a pandemic, but I also used it live in all my classes for in-class exercises and homework assignments. So here are some different classroom and homework use cases for TELLab. You could do a live demo in a lecture. We're going to do some of those today. Followed up with data visualization. So you could analyze the data in real time if you wanted to send a link and let all your students do, say, 3 trials or 10 trials of an experiment. And then you, as the experiment owner, could download the data and quickly show the class the results. You could have students do experiment participation and then do a data analysis assignment. So they can either analyze their own data, or you can collect the data from the whole class and send them out a CSV file of the data that the whole class participated in and have them analyze the results for homework. You can also do experiment participation followed by a design critique. So looking at an experiment, thinking, how can we make this experiment better? I'll walk through one example of that. And then where TELLab really shines is After you've discussed experiment designs, you can implement a new experiment, right? So you can discuss what makes for a good experiment, and then you can implement it, you can collect the data, you can do data analysis, and so you can do all of this on TELLab, and this works in a bunch of different use cases in the classroom. So you can do it as a whole class. You can have your, if you've got a smaller section, say 15 to maybe 25 students, but 15's a good size, you can have a discussion with your class about how to build a particular experiment. Which conditions do you want to include? What do you want to control? Do you want to run additional follow-up experiments? So you can have that discussion, have the class work together to design an experiment, and then you can build it really quickly on TELLab, and then the students can go share it with their friends or their family and collect data. You can also use it for group projects. So you can have students working together, either in the class if you have lab style classes, or for homework to design their own experiments, implement their own experiments, collect the data, and iterate. And another way we use TELLab is for independent projects. So seniors doing their senior thesis work, a number of them at Princeton, which is where I'm at, use TELLab to run their senior theses. So it works in lots of different use cases for educational materials about learning how to do research. So I want to give you one example that I use in my classes with TELLab. And it's an experiment participation plus design critique. So the way that it works is that we've got a bad version of Stroop. The students participate in a suboptimal version of Stroop, and then we do a workshop and they build a good version of Stroop. So they participate in one that's not well controlled, and then they work through getting to one that's better controlled. And so that simple design for the bad version of Stroop is a block design that has incongruent trials, one block of incongruent trials, followed by a block of just naming the color of a square. And I have students work in groups to come up with 10 problems with this experiment design. It's confounded in all sorts of ways. There's order effects. There's all sorts of differences between these two conditions that make it not a good Stroop experiment. And we work towards them coming up with a better design, a design that's better controlled. And so they end up getting to something like this, where they've got colored incongruent, colored words that are congruent, and then just naming colors on their own. And the blocks are all mixed together so that you don't get differential learning effects for one type of trial versus another type of trial. You mix all the trials together and that produces higher quality data. So it's just a better design. And that sort of action of taking a design that's not very good and figuring out how to make it better is incredibly useful for students. They often get to see final complete experiments. Maybe they read about them in journal articles, but they don't understand the process of getting from an initial design, an initial set of thoughts, to a better design. And you really can't get that except by doing it yourself with some guidance, by actually trying to build better experiments. And so a plug here, TELLab's quick design implementation makes creating new demos easy. And you might not have thought to make a bad version of an experiment, but it's pretty easy to do that. So you don't have to use Stroop. You could use any design that you want to start with, give students the example, and then make a workshop where they get from that not very good example of a design to a better design. And they could also collect data and compare the results. See if you get bigger effect sizes, if you get less noise once you've improved on the design. So the teaching philosophy of TELLab is really active learning. It's about teaching students about research by letting them do research. And I think that this is really important. I feel like there's too many research methods classes, too many classes in general, where they're trying to teach you about research, and learning about research by listening to a lecture or by reading a book is kind of like learning how to cook by watching the cooking channel while riding a bicycle. It doesn't work. You actually have to do research in order to learn how to do research. And so the types of activities that are supported with TELLab are letting students participate in experiments and then analyze their own data, analyze class data, letting them participate in experiments and then critique, participate, and then create a new design. And again, these different functionalities are available on some other sites, but where TELLab really shines is letting students implement their own designs and collect data. Then they can analyze the results from that data, and they can redesign. They can make a better version. So they can do a pilot and then another version of an experiment. And then they can implement that new design, collect data, analyze, and redesign their experiment. So the process of research is, researchers know that this is where the magic happens. It's running a pilot, it's getting some data, it's going back, figuring out, tinkering with the design, making it better and better. And TELLab is really ideal for this. There's not a lot of ways that students can get that type of activity without something like this, where it's easy to implement the designs, easy to collect data, and that gives the opportunity to think critically about your own designs and make redesigns and redesigns, and maybe you get 7 re-res here by the time the experiment's actually in great shape. So I'd like for folks here to create accounts at lab.tellab.org. It's free, there's no spam. It takes about 1 minute, and you're going to want an account to participate in some demos coming up. And we'll send you there. Yeah, we'll send you there again in a few minutes. So I'm just going to pause for 2 minutes and let folks go ahead and visit lab.tellab.org and sign up for accounts. You could maybe wave at me if you've completed the process. Hopefully it just takes a couple minutes. Yeah. All right. All right, I'll share my screen again and continue. All right, so you've got your accounts now, ready for demos. So why use TELLab? The basic reason is that the best way to learn is by doing. It's all online. There's no coding required for your students, and it lets you really simply display stimuli and collect response time and accuracy data. It also provides experiment design templates. So there's some quick ways to make new experiments for change detection, for multiple object tracking, for visual search, card sorting, short-term memory. There's a wizard to make implicit association tests, and some others as well. So why not use the TELLab 1.0? It's not built for surveys. It doesn't accommodate all different designs. And it's as is, so there's minimal tech support for 1.0. It was built a number of years ago. And the developer who built it now works at Google. So she's unfortunately not providing ongoing technical support. She's got her hands full with that. And version 2.0 is better, and it's under development. So if you want to learn about TELLab 2.0, please join us Monday at 8 p.m. or Wednesday at 2:30 Eastern Time. And you can learn about the system 2.0. So let's get started with an example of experiment participation using TELLab. So again, go to lab.tellab.org. And once you're there, you can click on experiments. So this is all the publicly available experiments created, some of them by the TELLab team, lots of them by students. And after you click on experiments, go to multiple object tracking. Once you've clicked on multiple object tracking, you can search for VSS. So there's a good number of experiments there, but if you use Command F on a Mac or however you'd search through a browser for text, you can search for VSS. There's actually a few versions of the VSS demos there, I believe now. Click on the chain link icon on the version that was created by Jay Wilmer. That's Jeremy Wilmer, he's a CoLab TELLab team member. And when you click on that, then you'll participate. So I'm going to stop talking and let you do a few trials of MOT on TELLab. All right, I'm going to continue. So this is the icon to click to participate, which hopefully you all just did. So after you're done with that trial, you'll get this screen that says, great, you're all done. If you're signed in, then you can click one of these buttons below to download your data. Long format is 1 line per trial, and wide format, if you're the experiment owner, is 1 line per participant. If you're not signed in, then these buttons don't work. But if you are signed in, you could download your data right now and take a look at it if you wanted, or save it and look at it after this presentation. Another way to arrive at data from experiments that you've participated in, so let's say you participated in, say, 5 or 10 different experiments, is you would click on My Home and then click on My Experiments, and that'll take you to a page that looks like this that has experiments finished. So all the experiments that you participated in, there's an opportunity to click and download your own data. There's also a column over here, which is experiments that you've designed, and it allows you to do more different things, which we'll get to in a few minutes. Yeah, so you can click which format of data you want to download for any experiments that you participated in while you were logged in, or all the participant data for the experiments that you've designed, either by copying them into your account and then making them live, or by designing them from scratch and making them live. So the next thing I'd like you all to do is to go to that same VSS 2020 MOT demo. And now instead of clicking the chain link icon, which lets you participate, click the copy icon, the 2 pages. And this is going to copy a version of the experiment directly into your account that you can then edit. You can tinker around, you can change the parameters, you can change the number of trials, and I'll show you how to do that in a few moments. So I wanted to walk through just an example teaching exercise using MOT in the classroom. This is something you could use in a research methods class. You could use it in in the precepts or sections for a cognitive psychology class. So the concept here is to workshop an inadequate experiment into a good one. And in the process, to teach students about what experiment control is. How do you design good, clean experiments that answer questions? And so you might start with something like 3 different conditions of MOT, easy, medium, and hard. So an easy condition would be, keep track of 3 items moving at 80 pixels a second and moving in a ballistic trajectory with no swerve. Medium, 4, more targets, a little faster and a little bit less predictable motion trajectories, or 5 targets, moving even faster and swerving even more. So this is not a good design, right? We've got 3 independent variables, varying the number of targets, the speed, and the motion trajectories. And so pretty simply, you can show students that if you want to understand the effect of the number of targets on performance, you need to hold these other 2 things constant. You need to have just one speed, one type of motion, and then systematically vary the thing that you're investigating, in this case, the number of targets. So I've taught a lot of students how to design experiments, and they all kind of want to start with something like this. They want to test everything at once, and they don't appreciate that you really need to control things. And so this exercise is really useful, and it might seem, too simple to expert scientists like yourselves, but students need to start with simple examples of understanding how to control things. And this is one way to do that. So you could have them, just systematically investigate performance with different numbers of targets, or you could hold the number of targets constant and just vary the speed and see how speed impacts performance. Right? So, or you could, hold these things constant and change the different type of motion trajectories. And so that helps students appreciate how you control things and systematically vary just the variable of interest. So I showed you how to create a new MOT experiment by copying an existing version, by clicking on the 2 pages icon. You can also go to where the multiple object tracking experiments live. So you click on experiments, then MOT. And when you're there, there's this big red circle, E+. If you click on that circle, that'll create a new experiment that then will live in the MOT section. So it'll be public facing. Once you're done with it and you press publish, it'll be in the multiple object tracking section so that people can find their way there and participate. So there's 2 ways to create new experiments. One is by copying an existing experiment. The other is by going where you want the experiment to end up and clicking the red E circle. So once you've done that, it'll say, successful, a copy of the experiment is in your account, start editing and publishing. To get to that experiment, now that you want to edit it, you would click first on My Home and then on My Experiments. And now experiments designed. And so you've got a new experiment here. If you clicked it with the red circle, it'll say new experiment. If you clicked it with the copy icon, it'll say the same name as the original experiment plus copy in parentheses. And when you want to edit the experiment, you click on this first icon, and that takes you to the experiment editor. So the experiment editor lets you make the changes. The interface starts off looking something like this. You've got frames, settings, and tags. When you click on frames, this opens up. This is where the experiment structure is going to live. So you can see it, and you can interact with it. And you can click this green icon that says, to add content, says add a frame. And once you click on that, you get some options. So I'll explain what each of these options are. First, if you can click text, that'll create a text screen. So you can type in instructions there if you'd like. So if you were to click this, it'll create an HTML frame and give you the option to edit the text. So to change the instructions, pretty straightforward. If you were to click the add a frame button and then select the MOT option, then that's going to create a new trial of multiple object tracking. And it's going to walk you or your students through the different parameters for multiple object tracking. So it lets you use an image if you want to use something other than just the simple black circle or blue circle or whatever it is. You can add a different image. And you can upload images one at a time or in batch to your TELLab library. And then you can select which image you want to use. Then it lets you enter the number of targets. So you can make it 1 target, 2 targets. And it has some helpful tips for students down below. In the multiple object tracking literature, people can track typically 1 to 6 objects. So don't try to make them track 25 objects. It's not going to work. So select the number of targets and then the speed. And again, it's got some helpful info for students. Velocity is measured in pixels per second. You can start by entering any number between 60 and 240. You can always change this later. So 60 would be a slow trial. Next, it sets some of the motion parameters. So anyone who's familiar with multiple object tracking knows that when you've got the circles moving around the screen, they can either pass through each other, they can bounce off each other, or they can avoid each other. And so if you set it to avoid, then it's going to give you an option to say how much should they avoid each other. So in this case, we set it up to two times the radius. So objects will get within 2 radii of each other before they bounce off or repel. There's also whether the objects are going to move ballistically like billiard balls, or whether they're going to spontaneously change their direction like a swarm of gnats. And so we call this noise. And you can set the noise to be, when it's at 0, it's like billiard balls. And when it's higher, the objects will spontaneously move and jitter around and change direction and start to look animate. So pretty straightforward. You can set up a trial. Once you've set it up, it gives you the option to duplicate that trial, to put it into blocks, to, and to modify the duplicate trials if you want. All right, so here's kind of general overview of what you can do with the TELLab experiment editor. Again, to use the editor, you go to my home, my experiments designed, then you click next to the experiment that you want to edit. And you can use the frames to add content. And the buttons are not all entirely self-explanatory. So I'm going to walk through what the different buttons do. So here we've got these options for text and image. So each of these will let you create a single screen. The text button will let you create a screen full of text. The image one will let you just upload an image, and then you can specify how you want to advance that screen with a button press or after a fixed amount of time. And then this button here will let you create blocks. So blocks can allow for a given screen to repeat, to be displayed in a random order. And let's students structure an experiment. So if they've got, say, 4 different trial types, they can make each one of those trial types appear 3 times or 5 times, and do it in a random order or do it in a fixed order. And I wanted to step back here and say that students can do a lot with just these basics. So just the ability to have text screens that give instructions, and then to display images and collect responses. There are lots and lots of different experiments that can be designed. They're not all great experiments, but some of them are. And opening up that possibility that students can design their own experiments and collect reaction time and accuracy data already opens the door to lots and lots of questions that they can actively ask. So one example of this is a flanker experiment. There's dozens, probably hundreds of different possible types of flanker experiments. The famous Erickson flankers, where you've got the task is to respond to the item in the middle, whether it's the arrows pointing left or right. And the main manipulation is whether the flankers, the arrows on either side, are pointing in the same direction or the opposite direction. So to make this experiment in TELLab, you just create images for these 4 trial types, upload them, and structure them into blocks. And I want to highlight an example of student creativity. A student in my class at Princeton was presented with the flanker context, sort of what's a flanker experiment, what's a Stroop experiment, and then we let the students build their own different versions of flanker tasks. And this one is it's a congruent, incongruent Star Wars experiment, where they took characters from the dark side or the light side and put them either in congruent backgrounds, so dark side character, dark side background, light side character, light side background, or incongruent trials. And so they made these images in PowerPoint and then just uploaded them. And now, like that, they've got an experiment. There's also a number of buttons for the add a frame that will let students make sort of specific select trials, so specialized trials. I've shown you the example of multiple object tracking already. There's also a way to make change detection experiments, and we'll do a demo of change detection in a few minutes. And there's a way to make visual search trials. So you can upload an image and then set which places on the screen would count as a target. So these are sort of specialized trials. There's also a couple buttons here that'll make entire experiments if students follow the prompts. So there's a prompt to make an implicit association test where you specify the 2 pairs of categories and then the list of stimuli, either words or pictures, and it builds a full counterbalanced implicit association test. Or there's a setup to build short-term memory experiments with lists of words. So that's sort of the big picture overview. These are all the different buttons for the types of content that can be added to an experiment. We've got single screens for instructions or for single trials. We've got the ability to add blocks that'll structure the experiment, presentation, and flow, allow repetitions, randomization. We've got buttons that'll create full experiments, and we've got buttons that'll create some specialized trial types. So now let's do one more demo. Have you go to experiments. So click on experiments back at TELLab, then click on change detection. And again, search for VSS. And I think that there's a couple ones that have VSS in the title now because some folks copied this version last year and made their own versions, but find the one that was created by Jeremy Wilmer, so J. Wilmer. And when you find that experiment, click on the chain link icon, and that's going to let you participate in a trial of change detection. So I'll be quiet for a couple minutes while you all get a chance to do that. All right, if you haven't found it yet, it's in the bottom left. I'll show you the trial. This is what the pair of images look like. It's photograph of the Harvard Vision Lab. And the difference between the two images is we added Jeremy from a different year's Vision Lab photograph into the image. And so, I don't know, importantly, it's really easy to make this trial, right? Students can take any image that they want, they can edit it in whatever software they want to do the editing in Photoshop and iPhoto, Keynote, PowerPoint. I recommend PowerPoint because it's, for this purpose, it's good at exporting images of a particular size. But students can make the trial, they can edit images, or they can, they can take photos and take two different photos where they've changed the scene in some way, or they can use an editor. They just save them as image files with max dimensions of 640 pixels. So the software does not make it easy to resize images. When you upload an image onto TELLab 1, it needs to have a max dimension of 640. So 640 by 480 is recommended. And once they've uploaded those images, they just follow the prompts and they've got a change detection trial. And change detection can be done side by side like this screen. It can be done alternating, sort of flickering with a delay in between. And that's nice. It gives students sort of a very quick way to implement an experiment design trial for something like change detection, to see where people's attention goes or what sorts of changes people notice or don't notice. So it's really easy to start making experiments. And to do this, if you wanted to make a change detection trial, you just click the change detection button and follow the prompts. So as I mentioned before, there's also a button to create a memory experiment. And this design is specially set up to reproduce the DRM paradigm, the D. Schrodinger-McDermott false memory effect. That's when you get a list of words that are all associated with a word that's not present. So sweet, candy, sucrose, etc. And it's all trying to prompt you to misremember that you heard the word sugar. And then in the test, you can put in your key foil and you can reproduce this DRM effect. And students really enjoy doing this. They like thinking of which types of words will associate and induce a false memory in their friends or family or their roommates. So it's a chance for them to reproduce a classic finding in cognitive psychology using their own stimuli and testing themselves and their friends. The implicit association test has proven to be the most popular content on our site. So the IATs have a lot of controversy around them. There's for good reasons and for bad reasons, but it makes a great experimental design to teach in the class because there's a lot of elegant design in the implicit association test. There's a lot of easy ways to misinterpret the data, and so you can get into sophisticated, nuanced discussions of what do the results of an implicit association test mean. And this website is set up to make it really easy for students to build their own implicit association test, and they can do it for serious topics that are in the news, or they can do it for whimsical topics. They can look at the effects of associations between, say, race and positive and negative for a serious investigation, or they could do a whimsical thing like Pepsi versus Coke in association to polar bears versus celebrities or something like that. The IET is really open-ended. It lets you test any two pairs of concepts to see how strongly they're associated based on reaction time. And students really enjoy using the IET to ask questions that are of interest specifically to them. TELLab also has some additional hidden functionality beyond the buttons I just showed you. So one of them is a card sorting template that can let participants make comparative rankings. If you wanted to make a card sorting experiment, you could go to people watching, so experiments, and then people watching. And if you click the red circle here, then when you go to edit that experiment later, it's going to add this button here called card sorting. And the card sorting interface lets you upload some number of images and then drag and drop them into a rank order. So again, this is a type of experiment that students typically enjoy participating in, and they have questions that they want to ask. You might have participants rank faces on trustworthiness, and a separate set of participants rank faces on attractiveness or dominance or likability or some other trait. So just drag and drop them from most to least, and then see whether those rankings are correlated. Are trustworthiness and attractiveness correlated? The students can very easily design that experiment. They can do it within subjects or between subjects. So they can make one version for trustworthy, send that to one listserv, and another version for attractiveness, send that to a different listserv or a different set of friends to participate in, and then look to see how correlated are those ratings, or those rankings using this card sorting task. So the last point that I want to make today before opening up for questions and for discussion is that TELLab also makes it easy for students to download their data. So once you've created an experiment and run, you just click on, so this was the edit button. This is the download results button. Got this pause button when an experiment is not currently live. From the editor, you can publish, click save and click publish to make an experiment live for the world. Once an experiment is live, if you want to make it no longer available, you can click this pause button, or you can click the X button to delete an experiment. But this one here will let you download the results, and it lets you choose between two different data formats. So the two formats, as I mentioned previously, are long. Long format is one row per trial. And so after a student's participating in an experiment, I recommend having them download their own data in long format, and they can see that their experience from 3 minutes ago was, hey, I just did that produced this line of data, then this line of data, all the way down. They can see what every row of data means and link it directly to their experience as a participant. The wide format you typically use if you've got lots of participants, so a student maybe analyzing data from the entire class. And this has one row per participant. So it's good for looking at item effects for different trials. If you want to run that type of analysis, each column is the response for one particular trial of the experiment. So you can look and see, were these types of trials easier or harder for people? Were there main effects? Where were the most errors? The wide format facilitates that. It also facilitates looking at individual differences, so comparing performance between participants. So we've got both of those formats available on TELLab. And so now is the time to plug TELLab 2.0 again, which is currently being developed by Jeff Mulligan. I see Jeff is here. We'll be giving presentations, and I should say that TELLab 2.0, it's currently being created by Jeff with helpful contributions from dozens of great people, hopefully including you. So if you want to get involved in the TELLab project, if you want to use it in your class, if you want to share materials, or if you're interested in helping coding some of the new functionality in TELLab 2.0, we'd love to get you involved. So I'll end there. We've got presentations on TELLab 2.0 Monday at 8 p.m. and Wednesday at 2:30 p.m. And I'm going to stop sharing and open up for questions and discussion.